beginner, experienced, and intermediate data engineer. We collaborate and ensure we provide this collaborative platform for data engineer to thrive. And thank you so much for joining. Today's webinar is on simplifying Data Lakehouse. If you don't know, this is the second time Ahmed will be presenting on this. We had another webinar with the community about 10 months ago, where he taught us about how to get started with the open source lake format. So it's really nice to have data guy on the call. That's I nickname I do call him. His full name is Ahmed Oladapo, and today he will be taking us through how to simplify Data Lakehouse. Ahmed Oladapo is a very and highly experienced data engineer. He has over 8 years of experience and currently works as a senior data engineer at Page. I hope I pronounced that well. Today we'll be taking us through a candid look at the pain points in modern data lakehouse architecture. We'll be taking us through how to simplify doc lakes components using 3 lines of SQL code. He will be doing a lot of reward demo. So feel free to enjoy this call. Before I hand over to Ahmed, please, if you have any question, you can drop it in the chat. I'll be looking out for that, and let's have an amazing time. Ahmed, over to you. Ahmed, can you hear me?
Can you hear me? I can hear you. Can you hear me?
Yes, please go ahead.
Just a minute. I don't know what happened. I was trying to set up my screen, and the screen disappeared.
Oh,
okay. Just continue with something and give me like 3 minutes, please.
Okay, no problem. I guess I'll be getting more familiar with our audience. Emmanuel and where are you joining us from?
Strange.
Emmanuel,
Yeah, I'm
can
joining
you
from
hear me?
Nigeria. Yeah, good afternoon or good evening.
Okay. How's your weekend going?
I don't know because I'm still working, so there's no weekend for me.
Wow, that is an interesting one.
I think I'm back now. You can hear me.
Okay. Yeah, please go ahead, data guy.
Okay.
All right. Thank you. All right, thank you, everyone. Good evening. My name is Ahmed, and I'm a data engineer, just a data engineer. And I like doing things that has to do with data. And today, I'll go ahead and share my screen. Sorry, guys. Share screen. Okay, so let me know where you can see my screen. Can you guys see my screen now? Please, somebody should let me know when you can see my screen.
Yes, I can.
Yeah. Yes, we can.
Okay, good. So the last time we talked about open source data lakehouse, and I know a lot of people that are joining us, so I'll be showing a part of the slide we used the last time so that everyone can have an idea of what we're talking about. So I'll make it very fast because we have a demo, and we'll see how it goes from there. So if you hear of Lakehouse, if you are very new or you are not part of the first session, have you heard of the word Lakehouse before? Anyone? 10 seconds. Anyone? Anyone? Okay, what of the word data warehouse? Okay, please go ahead.
Yes, we've heard a lot about, in fact, about Data Lakehouse.
Okay, good. All right, so before now, right, mostly when it comes to big data, people tend to have a lot of problem. And the reason is because data is so big that a lot of things we do becomes very, very difficult for us to make a sense of it. When the data journey started way back in the 70s, people were not thinking we're going to have data this big. So we're just doing some modeling, trying to decouple analytics away from the regular transactional data. And we're able to do that. And you start hearing of people building warehouse, you start hearing of people doing Kimba modeling, Imon, and a lot of things. And the idea, the concept behind those things is that you only take the data you need and then model it to help business. You model it to help business make decisions. That's the idea behind people building warehouse. That's why when you see people build warehouse, standard warehouse, enterprise data warehouse, they don't bring everything. They only bring what they need for the phase where they are building warehouse. And the reason is because then you don't have good data, AIs were not available, and the business only want to focus on what they need. And then storage was a very, very big problem. To be able to store things were a big problem. So the only model was needed. But I think around 1998, 1999, a lot of things changed. And then people started generating huge amount of data. Then I can sit on my phone and in a month generate terabyte of data. And people don't just want this data to sit down there. Because as data professional, as scientific people, we don't make decisions based on how we feel. We get facts from data. So we can't allow this data to just sit down there. We want to go into this data, use it for decision making. I don't want to make a decision because probably I slept on one side. Anytime I sleep on that side, Chelsea tend to win. So I sleep on this side today, and then if you are the type that go to bed, you go to bed and says Chelsea will win. Because I woke up on this side. We don't do that. So we want to get facts from our figures. So because that's what we do scientifically, people started thinking, okay, this amount of data that is so huge, what do we do? It was a big problem. And they started a lot of tools, big data problem, big data solution, Hadoop. You hear people talking about Hadoop. It was a breakthrough. Hadoop was a breakthrough. Distributed system was a breakthrough where we now able to process data without taking data away from where that data was. No, before, if you want to process data, you take that data out, it goes through the tool, from the tool, you put it back. Then all of a sudden, people brought in technologies that does not take that data out, that will go and meet that data where it is, and then process it there. Because if I have terabyte of data, and then you want to bring it out, process it, take it back, it's forever, it takes forever, and you spend a lot of money. So people started doing a lot of things. And because of a lot of this problem, people started thinking of solutions. And those solutions gave birth to a lot of things. There were a lot of problems. And then they brought in people who are data engineers. So before now, they were not data engineers. They just maybe SQL developer, database developer. And that gave birth to people who are those that will focus on fixing this problem. So that's why you are now here. We are data engineers and we are looking at becoming very good at it. Right. So, like I said, I won't spend too much time here. And then now, let's drill down into Lakehouse and see where you started. Now, for every database is where you store data. Before now, when you are trying to store data, you start thinking of how big is my data or how small is my data. Maybe on your phone is where you are storing your contact before. Let's say you became so big that your contacts could not fill your phone again. And then you move them to Excel. And then you start having a lot of contact business and everything, and all your business data on Excel. You get to a time when they become so big, and then you have to move them out of Excel into a database. Now, database probably is the safest place to keep data, and it's because of the design, how it was designed. Every database you work with, they will have these 4 components at least. They will have a storage, the place where you store data. They will have what they call a table format, right? That allows that table to be in a structured format. So most times the data you keep in there may not actually be structured, but the table format allows that structure to come in. Then there's a catalog, right? That is able to say, oh, the data you enter here, store it in this table, and it will keep a record of where you keep everything, right? And then there's a place where you process. That is when the passing, the planning, the execution, that's where it takes place. And then for database, these data are stored in rows and columns, but we call them rows. That is how our database comes in. But this type of design is very good for what they call transaction because it is stored in rows. And then as time goes on, people start building warehouse. And then for the warehouse also, the same components, a storage. There must be a place to store data. If you don't have a place to store data, you can't have a warehouse. If you don't have a table format that allows those things to be in tables, you don't have a warehouse. If you don't have a catalog that will be able to analyze things and say, ah, you be here, you be there, you be there, and then the processing power. So that's warehouse. But the difference is that in warehouse, we store data in columns, which make it very fast when you are trying to filter and look for things. And then when data became so big, like I said, people started thinking of a lot of things to do. Not only that, if I'm using a particular database, if I want to leave tomorrow, the only thing they will probably give me is my data. I may not even know what is going on in the storage table, format, catalog, or the processing. If I'm using Postgres, they don't care. I don't care about that. The same thing the warehouse too. So there's something called vendor lock-in. And because we have huge amount of data, people want to experiment, they want to have control over data, they want to be able to wake up one morning, switch tools, switch this, switch that. If you have a data, let's say in one of these MPPs, and we call this what the massive parallel processing, let's say Redshift, BigQuery, or Snowflake, you're keeping your data in that kind of a place. You don't even know what processing is going on. You don't know the catalog they are using. You don't even know the table format they are using. You don't know how they are even storing it. You just know your data is there. So sometimes you cannot wake up one day and say, okay, I want to change the table format they are using for me. I want to switch the catalog. I want to change the processing. Maybe we're using Trino. I want to change it from Trino to Spark. You will not have that kind of access. And because these data sets are so big, people want to have control also. So that's when this idea of a lake house comes in. Now, for lake house too, we have what we call the storage also. That's before we get to the lake house. So there's data lake. Everybody knows about data lake. Data lake was so popular about 5, 6, 7 years ago. Almost everywhere you go to, you need to build the data lake. Companies will be shouting they want to build the data lake. But the problem with data lake is that data lake is just a storage and then maybe compute. So the table format and catalog is missing. So now you have a data lake, but what you enjoy in the database because of the catalog and table format, and what you enjoy in the warehouse because of the catalog and table format, you cannot enjoy it in data lake. Why? Because it's missing two very important components or ingredients that makes up a place where you store data that you can process. So data lake was supposed to be a breakthrough. It became a problem that people will store data and keep it in their data lake and keep it to the point that they cannot do anything with it. In fact, I have friends that we work together doing very well. One of them even a CTO now does not even want to hear the word data lake because as far as it's concerned, it's just another place to store data and mess things up. And it's not far from the truth. Right? In fact, if you have a data lake and you didn't treat it well, it becomes what they call a data swamp. I know what happened to a swamp. So people were battling with this problem, but one way or the other, it's a step in the direction that we really want to go to. A step in ensuring that we can take over these things and let it be our own. We control our storage ourselves. We control our table format ourselves. We control our catalog and processing ourselves. Data Lake was a step in that direction. It already gave us access to control our storage and our compute. But those other two things were missing. And then one of the problems is because most of data we store in Data Lake, we store them in a format called Parquet. Parquets are format that you cannot really write on. You can't make updates when you write. So it was a big problem as at that time. Now, this now takes us to where we are going today, Lakehouse. Now, Lakehouse comes in to come and fix all of the problem you can think of when it comes to having access to your data, storing your data, choosing the tool you want to use. Like you want to be in control of the tools you want to use. You want to be the one to make decision as to which tools you want to use, not because you're using a particular vendor and that vendor is saying this is what they have on their system. You're using AWS, you have to use it. No, you want to be the one to pieces each of these components and pick what you want. And this is how the component looks like. Now, for the storage, I can decide I want to store my data in S3. I can say I want to store in Azure Bob. I can say I want to store in Google Storage. I can say I want to use MinIO. I can even say I want to use a folder on a server. So I'm in charge of my storage. I can do it the way I like. So let's take another steps. Now, the lakehouse formats. There are three that are very, very popular as of last year. We have the Apache Iceberg. We have the Delta Lake from Databricks. And then we have another one called Apache UD. So these are the things that makes it easy for us to turn our packet and be able to write on top of it in a way that it turns it to a table and people can query it, right? And then the next thing is catalog. Catalogs are very, very, very important, right? You have Apache, Apache Nisi, you have Polaris, you have Hive Metastore, you have Unity Catalog. These are called catalogs, right? We'll probably still drill into what catalogs really do. And then the last format is I can choose anything. I can choose anything. I can choose a DocDB. I can choose Spark. I can choose Trino. I can choose Presto. I can choose Dremel. I can choose Flinks. I can choose anything. So let's assume we want to build a lakehouse in our office now. We'll choose a story that we like ourselves, that we think our people can work on. We take a data lake format that we feel like we want to work with. We choose a catalog ourselves. We choose a compute we want to use. I know what that means. That means I have a data lakehouse. I have something that is a data warehouse, a data lake, and then maybe a database all together. And I don't have to rely on Postgres. I don't have to rely on MySQL. I don't have to rely on Redshift. I don't have to rely on BigQuery. I don't have to rely on Snowflake. I don't have to rely on Azure Synapse. I don't have to rely on Azure SQ. I think that's what it's Azure Synapse now, Azure Warehouse. And I don't have to rely on Fabrics or anything. I can put all of this together and put it in my backyard. I can spring up one server and put it there. I can spring up Kubernetes. I can do anything. And I'm the one in charge of everything myself. And I have a world-class standard lakehouse. So that is the idea behind the lakehouse. And the good thing here is that everything here is open source. You're not paying for any of the service. So that's what we are going to talk about. And that was what we talked about the last time. And it was actually a pain because you need to be a little technical for you to use some of the things that are here. So our focus today will be on a new table format and catalog that we have brought in. Don't forget what I said, that if you have a storage and the compute, but you don't have the lakehouse, you don't have the table format and the catalog, you only have a data lake. You don't have a data lakehouse. That means for you to have a data lakehouse, that means you must have the table format and the catalog. That's the most important thing for you to have this. So, but setting up this, there's always been a huge amount of problem. A lot of people have been having problem with catalog. There have been catalog wars. Databricks had to come up with Unity catalog. Snowflake has to go with Polaris. Hive Metastore have been there, but a lot of people are trying to stay away from it because it can mess up things. Although I think that's what AWS is using. Maybe that's what powers it. There's also Glue. Yes, there's Glue from AWS. I think they also leverage Hive Metastore. You know, people have been having work because they know catalog is so important. For the table format, Iceberg has been the king for a while. Then these people woke up. Databricks, they built their own and said, okay, what determines the format? And they built Data Lake, Delta Lake, right? And this is what is that's going on for a while until about 2-3 months ago. So people came up, but we'll get to that. So this is the war that has been going on. And that war is still very, very much. If you have been following data news, you will know how important this is. A lot of big companies are buying small ones that are building this technology because everybody knows that with the way we produce data everywhere, in another 2-5 years, 10 years, people will not probably using some traditional database again. They will move into some of these lakehouse. So if you are a data engineer, you have to start preparing yourself for what is going on in the market, understand the news. Now, if you want to build something with a lakehouse, this is the architecture. Every one of us, we are aware of this. We have a place where it's called source data. Then you have layers. You have the bronze layer where your data drops. You have the silver layer where you clean it up, and you have the gold layer where you produce something that the business can connect to and make a sense of it, right? And from what you can see, you'll see that all of them are stored in storage. So this is what we are talking about. Just imagine that you take data the way you have it, and then you put it in a folder, and then you are able to query that folder, you're able to write SQL against that folder. Is that not awesome, guys? Like, you just take data the way it is, you put it in a folder in your system, and then you're writing SQL code to look at that data. You're using SQL code to build automation on that data. That is exactly what this Lakehouse thing brings out. So every container you see here, there are folders. This bronze layer is a folder. This silver layer is a folder. This gold layer is a folder. Now, not a database, not a data warehouse, not a database, not a data warehouse. That means I can build a warehouse without actually paying or buying for a warehouse. All I need is just a folder somewhere, probably in a server, on AWS, or in my company, anywhere I want to keep. Maybe, I don't know, maybe just one server somewhere and just put it in there. So this is the architecture for a data lakehouse that people normally work with. Of course, you can come up with anything that comes to your mind. And then look at this now. If you are using the first three that people have been using before now, that's Iceberg, Delta Lake, and Hoodie, you end up having something like this, where you have, this is, if you can see Iceberg here, Iceberg is your table format. The NIST you are seeing here is your catalog. Without these two, you don't have a lakehouse. So you have to have this, and have this, and have this. So that means you need those two for you to do anything. So this is just an example where you have to use either Iceberg, Delta Lake, and everything. And then you also need to use any tool. So in this case, there's Trino, it could be Spark, it could be anyone, right? But by the time when we had our first demo, I think we used Trino, and that's why we have Trino here. Now, this is where the edit is, right? When you want to query data so I'm putting Iceberg, it could also be UD or Delta Lake, right? It needs to go into the catalog. I don't want to waste time on the catalog today because I explained the catalog, Iceberg, everything in the first video. So that's why it seems like I'm rushing all of this part so I can get to what I want to really do. So when you query data, it has to go through a lot, go to the map. There's something called manifest JSON, there's also called manifest list average, goes in there. It will first of all go to the catalog. Let me give you an instance. You go into a library, right? And you need a book. The books are the ones here. They are the data file package, data file to package. Those are the books, right? But when you get into the library and you say, oh, I need this book, the librarian will probably pick out their catalog. So that's what is happening here, right? It picks out the catalog, it will read it, That is how it's reading. So it will be going, oh, maybe the catalogs are stored alphabetically, or you say the name of the book you want to read is How to Become a Millionaire. So it knows that it's W, or maybe it has an author and it goes through the author name. So it will go in. That's how Iceberg does his thing. So it has a metadata. You know what the metadata is? Data about your data. So the data, this is our data here. This is the data we store, maybe customer data, client data. This is the data we store. But the data about this data is what they call a metadata. The data about your data. The information about your data, the data about your data. So for your query engine, whether you're using Spark, whatever it is, to be able to give you what you want after you've written your query or written your code, it will first of all come to this man and say, oh, you are the one that owns information about these people. So these are the books I want. This is the librarian. He comes in here, he checks all of this, he goes in up and down, and they say, okay, I've seen what you want. Then he comes in here and so that means if your catalog is not okay, you're going to have a lot of problems. So that means Iceberg on its own will not do what you want. You need a catalog. So these things were headache because for you to set these things up, you need to have a server that is running your catalog. You need to write the server that is running your engine. I think that was what we demoed that day. We had a CAP server for Apache NSC, I think another server for Chino. So you need to be calling those servers for you to be able to do something. And that's an headache on its own. In fact, some people find it difficult to set up in production because they have to have different server for this, different server for that, different server. So that's the headache people are facing now. And everybody's looking at, is there a better way to do this where everything is bundled together and we don't have to be looking for things here and there, right? So now that brings in Data Lake. Data Lake came in to come and fix this headache, and that's what we're looking at today. What we're looking at today is called Data Lake, right? And they came in and said, okay, is there something we can do to fixing this problem? Make sure that people don't need to spring up something difficult to have a lake house. Make sure that people don't need to spring up something difficult to have catalog and anything working. Can we even have something that combines both table format and catalog together without us looking for Apache Iceberg, Apache this, Apache that? So Data Lake came up with something, and they say, okay, what we are doing is your data is here, your metadata is here. And that's what Data Lake has come to introduce. That means I don't need the server to run catalog. I don't need the server to run engine. I don't need the server maybe to run for paper format. Everything is already in one place. Catalog data, Data Lake should be like 4 or 5 months old now, and it's very, very promising. A lot of people love it. A lot of people are still probably looking at it and say, okay, where are they going? And few people are like, oh, I love it so much, but I don't like the fact that they put doc there. Anything that has doc, we don't like it. A lot of reaction on the internet. But we are not here to discuss the reaction. We're here to discuss how we can profit from using this and what this can help us do. Right. Now, before we go into the demo and everything, there's this part I also want us to see. So it makes a lot of sense to us. If we look at, call it Data Lake versus everybody. So for Data Lake, now in Lakehouse, we store data in Parquet mostly. So you have your Parquet here. Then your server that stores your catalog is not a server in Data Lake. It's just an SQL database. Now, the first time I saw this, the first question that came to my mind was, if I store my catalog in an SQL database, will this not get filled up and be giving me a problem? So I started doing my research, and I found out that the catalog itself is not even up to 1% of the data. So if I have 1 terabyte of data, my catalog will be like maybe 0.1. So that's how much the catalog is. That's what they've done with Data Lake. So it makes it easy for you to store. We're still going to go there. But this is the difference. Now, all other methods were not really a problem, but the problem is here, the catalog API. Having a server, it is a problem. So you can't really move it into a place. It becomes a problem for everybody. So, and that is what Data Lake will come to fix. When we see practical and some things, a lot of things will make sense to us. And now, what are those components? The same component that you see in every other lake house, but Data Lake now makes it very easy. Right. So just like the other ones, you have a place where you keep your data. So you can keep your data in your local system. You can keep your data in a folder. You can keep it in the cloud, in the storage in the cloud, AWS, Azure Blob Storage, Google Store, anywhere you can keep it there. And then it has a metadata store, right? You know, I talk about data about data. That's metadata. So it has a metadata store that can also be stored anywhere. See, this is one of the most beautiful part of the whole thing. I can store my metadata in a database. It doesn't have to be beside my data like the other ones. I can store it in a bucket. I can store it even in DocDB. I can store it. These are the 3 things that they are presently. Maybe they will keep on working on it. And then lastly, you can use any engine according to them. But for now, being that is very new and it's still going through a lot of iterations, for now, the engine that is only available probably is DuckDB, right? Although they are saying at every opportunity that Duck Lake is not in any way related to DuckDB. But the query engine available is now. So let me now come back to this place. So Duck Lake is table format plus catalog. That's what it is, right? Table format plus catalog. That means Duck Lake is the same thing as our Delta Lake plus a catalog. It's the same thing as Apache Iceberg plus a catalog. The same thing as UD plus a catalog. So all of these are catalogs. So I can change this to the Data Lake plus Nessie, Data Lake plus Hive, Data Lake plus Glue, Databricks plus Nessie plus Polaris. So Duck Lake is table format plus catalog. So it's like the combination of these two things that were a problem. So they became the two of them. So if you have if you have to write a lot of code to bring up your server for the API to do this, Duck Lake just gave you 2 or 3 lines and you bring everything together into one. We're going to see that. And then the architecture has changed. If you look at this now, you cannot see anything like Nessie, like Polaris, like you can't see anything. Even Iceberg, you can't see Iceberg. You can't see. I love Iceberg so much. You can't see Iceberg, and I'm still looking at what Apache Iceberg people will do, because if nobody is doing something, Duck Lake with what they are doing, if they continue, will probably take over the market from everybody. So, but I'm routing for some people. So this is it now. All of those technology that we had before, they are gone. I have a friend who so much love this, even though does not do data again. He doesn't like those technology for whatever reasons. So he will so much love this. And then, so we can go to our demo. Before we go to demo, is there any question? Let me come here 10 seconds. Any question? Any question from anyone? So if what we've discussed
Yes,
looks, okay, please go ahead.
I have a question.
Please go ahead.
Okay, so good evening, everyone. My name is Muftar Abdurrahman. I'm joining this demo from Nigeria, Abuja. Okay, so it's quite amazing what you talked about Duck Lake, and in fact, I won't lie, this is my first time I'm hearing about Duck Lake. But so far, for what you said, it looks so amazing, and it's something that needs to be explored in order to expand our capability in data engineering. So just my question is regarding the Duck Lake. I still just want to understand, is it that for you to actually experience the capability of Duck Lake, does it mean that you have to host it on your server, or it's something that you can access online on platform just like the Microsoft Fabrics, Databricks, and the likes? Is it the same thing, or I need to install it, or sorry, deploy it on my server before I can actually experience the capability it has?
Now, this is good. Good question. So let me answer a question very fast. Now, before you think of this, let me ask you a question. Are you aware of Lakehouse? Do you know what Lakehouse is?
Yes, I know what Lakehouses are.
Good. So now, before you start thinking of even maybe using Duck Lake or anything, you need to ask yourself, what do I want to achieve? Where am I going? What are the things I want to do? So now, a lake house, every other lake house you want to build, like I said, you need 4 components. You need your catalog, you need your table formats, you need your storage, you also need your compute, something that will be using the engine that will be running it. Now, for you to do this now, you can do it right there on a local system, right? If your system has a storage, you can do it on a local system. You can also host it in the cloud. That's the beautiful thing. So I can put it on AWS S3. You can put it on Azure Blob Storage, the same thing. But we're going to do a demo where you see. So I'm going to do 2 demos very fast. One of them is going to be just setting it up normal on a local system, and then the other one will be if you work in a place and your company is looking at setting up production grade lake house. Also do a demo on that. I don't know if that answers your question.
Yes, it is. It does. Thank you.
Any other question? Another
Yes, there's
question.
actually a question in the chat.
Okay. Why
From
we want
Joseph
to change
Ojo.
table format? Okay. Okay.
Yeah,
Okay.
yeah.
So when your guy is asking you questions, it's okay. So why would you need to change your format? There are a lot of reasons why we need to change that, right? Compatibility with tools. Let's say you're using Delta Lake already, and then you wake up one morning, and then there are things you want to do, and those things are possible in Iceberg and is not possible in Delta Lake. Right? You start asking yourself, so your tools matter. You know, when you are doing this particular thing, you're already at the point where you want to be in charge of the tools you are using, be in charge. You don't want to rely on any company tool now. You might still use a company tool, you might still use anybody's proprietary tool, but you have flexibility now to do whatever you like. So the first thing is, we don't want to use this table format, we want to use a different table format. So that's the first thing that comes to my mind. Another thing that comes to my mind is that sometimes you want to look at performance and scalability, right? You also want to look at future requirements. What are the requirements that we need to put into what we are trying to do? So everything is based on what we want to do and what that particular table format can offer. People make a lot of mistakes. They assume all table format they do the same thing, but there's a reason why one is calling their own Iceberg, one is calling their own UD, and one is calling their own Delta Lake. On the surface, to everybody, they do the same thing. But trust me, like I normally try to tell people, there are some people that just go to their radio and switch it on and listen to what the radio is saying. And then there's a category of people who also know what is making noise in those radio. Now, for everyone, if you go to the radio and switch it on, all the radios are the same thing, right? They are all making noise to your ear. That's what all the radios are doing. But by the time you go inside the radio, you see why they will sell this radio for 100 naira, and they will sell the other radio for 10,000, and they will sell another radio for 1 million. There's a reason. So to the regular person, all of them is ready. Just switch it on. It's just like a car too. To everybody, just enter your car. You need cars to move us from here to that place. But when you enter some car, you find that you are no more on earth. You are now in heaven. Sure, you understand? That's how catalogs are too. There are features you will need that one will have and one will not have. There's some flexibility based on maybe you're building a product that is not common there. And then you need a particular feature. There was a time that Delta Lake does not have time travel, and it was an issue, and people wanted time travel by all means. You know, you look for a lot of things, and those are the reasons. I don't know if I answered our question, Joseph. You can just give thumbs up or thumbs down to let me know if you answered our question. You can just drop a message so I can move forward. Okay, so I don't know if I answered his question.
Yes, please go ahead.
Okay, good. So now, so I'm just going to do a very, very short demo of how it works, right? And then we'll do real life demo. When am I supposed to be true? Miss Lee, like how many hours do you have left?
Is it 2 hours webinar?
Oh, good. Okay, so we have much time. Now, before I go into anything, I like to always show documentation, right? So let's see what almost passing out. So look at the documentation. Look at what they said. They said Doc Lake is an integrated data lake and catalog format. So what they're saying is that the part where you have the catalog and the table format type, it has been integrated into one. So you don't have to have them separate again. It comes in as one, right? And you know, people will not listen when you bring up things. Then they showed us this. They showed us this. This is where the beauty is. You can choose whatever you like as your catalog database. So I can pick DocDB and say, oh, so now that means instead of having different layer, everything is here. All my catalog. Now I told you how important catalog is. You go to a library, you don't even know. You go to, let's say you go to a library, there are some libraries abroad, and if you enter those libraries, you'll be asking yourself, how do they know where books are? That's how big they are. That's exactly a real life example. Without catalog, you can't know where a table is. You can't know anything about what is going on in here. But because we use database and data warehouse, and then Snowflake already help us package everything together. So Snowflake has all these 4 components. Postgres has all these 4. Any database engine you think of, they have all these 4 components. But the thing is that they have bundled them together. We don't see it, right? You just go in there and say, okay, this woman that is selling rice, can you please give me rice? Can you please give me chicken and chips? Can you please give me? And then you collect everything and you hit. You do not understand that the person who made that food has to go out, go to the market, buy pepper, buy salt, buy yam, buy this, bring them together. So Postgres is doing that for you. But the only problem is that if you want more pepper, more salt, more oil, Postgres may not be able to add more oil for you. So that's where people build their lakehouse so that they can have control over a lot of things. Also control cost. Cost is always very important and do a lot of things. So they give us a lot of options. I was reading their documentation and I said, this one can be buggy, this MySQL, because they are still building SQLite and this, right? So we'll see how important these things are. And then if you come in here, for me to get a lake house working, right, all I need to do is run this. That's all. That's all. I'm not running any Docker Compose. I'm not running one Polaris, one Apache server. You're not running anything. All you need to do is just to install Doc Lake, then attach it. That's all. So because you are running it on a DocDB, you don't need to specify the catalog. Everything is already here because it knows. If you're using SQLite also is built in. So I'm putting it here that you are doing SQLite. SQLite is just a small database that is built into a lot of systems. Right. It's very popular if you do a lot of things in Python. Right. And this is where to be storing data. And then in Postgres, the same thing. You attach the lakehouse. You give it the host URL, that's the host, the password, the username, you put in everything in here, and then where you are storing the file, which is this is your real data. So your catalog will be in this place. Your data will be in this place. And then the same thing with MySQL. Your catalog will be in this place. Your data will be in this place. So that's the beautiful thing that this one has done to us. Let me see if I can use Excalibur to show us a few things, since I know I still have like extra 1 hour. So let me slow down a bit. I was rushing the other one because I thought I had just 1 hour for the whole thing. So let's see something. So what we are saying is this. You are working in an office. This is application, right? And then this application is talking to this database here. Let's call it a bank app. Now, if you come to this bank app to make transactions, what normally happens is that it speaks to your database. It asks if you are authorized, you get information and it sends it back, right? So you store data here. But as time goes on, this bank app, you have a lot of customers and you want to make decisions from it. So what do? You connect to a warehouse. Some people do a replica, but I'm just trying to make it very fast. You connect to a warehouse. Now, this warehouse provider most times can be Snowflake, can be Redshift, can be BigQuery, etc. And then it is from here that you now do all the calculations you want to do so that you can get information that you give to government officials that are the statutory body, information that you use to build a lot of things, to create more complaint, to do a lot of things for your customer, to serve your customer. You do all of that here. Now, these engines you are seeing here, they have those 4 components that we talk about. So they have these 4 components that we talk about. One of them is that they have a place called storage where you keep data. They have something called table formats. That's what allows you to actually store your data in tables and row, right? They have a catalog. And then they also have an engine that allows us. So when you run things and it's very fast on this warehouse, this warehouse is fast, is this, is that, it's because there's an engine under it. Without the engine, they will not run. This same thing you have here is also what you have. It's also what you have in this place, right? Now, you now woke up one morning and you because you have huge amount of data. Storage, most times you go online and then you go to do your findings and you find out storage is very cheap. So you find out that you want to build your own. You don't want to rely on Snowflake, Redshift, anybody again. So you are telling yourself, okay, storage is cheap, right? So you go to do your findings. It's okay, I can use Amazon S3. It's a storage, is very cheap. Or I can even use a free one that will just put in a server, it's called MinIO. It behaves like S3, but it's free. You can put it, you can install it on any server. So it's okay, we'll do this. And then you start asking yourself, what are table formats? They tell you there is one called Iceberg. There's one called, so let's go with Iceberg. And then you ask yourself, what catalog do I want to do? And then you come in here and you say, okay, I want to use Polaris. And then you say, okay, which engine do I want to? I love this engine very much. It's called Trino. I think Presto. That's the name. I love that engine. It's an SQL engine. Very, very powerful. Very, very powerful. Or maybe powerful than Spark self. So now, all of these 4 things, you're not paying for any one of them, right? So you decide to bring all these 4 together and you have your own self-built Snowflake here. Now, you might be asking yourself, why do I need to do this? Why can't we just go ahead and use this? Now, sometimes most companies don't even want to build anything because it's even more expensive to build even open source. Because people who built it might leave and you'll be having a problem to get people who come and be managing it after those people left. But sometimes you also find yourself in some type of field where regulation will not allow you to store data on Snowflake. Maybe some of us don't know. There are some fields that when you find yourself in those fields, you can't store data in the cloud. Let's say you're working for government, you're working for security. There are a lot of rules when it comes to data governance that I think a lot of people don't know. For instance, now, I think I've been on a project for Nigerian government before with Nigerian police and with Security Exchange Commission. And by law, government data is not supposed to be stored outside of that country. It has to be within that country. So that's why you see that most of the things they build, they have to build a server room, right? All those MTN, by law, I don't think they have right to store customers' data outside of Nigeria. That's why you see a lot of them are building data center up and down. So there's a lot of law that governs this. And now you want to build on your own. So you have to go to Snowflake and say, Snowflake, can you build something for us here? And they come and quote another 100 million and they build something for you on the inside. So these are the problems big corporations that have security concerns and that have statutory control are facing. And that's why you see that there was a time, I think Microsoft and AWS were trying to come up with something called .gov. a center, what do you call that? A data center, right? That is .gov. So it's only government of countries that will be there, and they give them guarantee that your data is safe. I think they were even trying to demo it by putting those servers under the oceans or in the ocean, as the case may be. I think there was a time they were demoing. I don't know if of us were following that news. I think Microsoft did one where they had to put that server inside water for 20 years, and they found that it performed better than the ones that are not even inside server. A lot of things are going on. So because of this, because you're asking yourself, why do I need to go through all of this to do this? So a lot of people are doing this now, trying to decouple all of this to give them this, right? And as soon as they are doing that, they found that this is working fine. But this part has always been a lot of problem. This part where you have catalog. And then a little of these parts. And it is these two parts that makes a data lake to become a lake house, right? These two parts. And then there have been problems. Different table formats, the maturity of the table formats, different. The behavior is different. And then the catalog, like I told us, is the most important thing. Without the catalog, you can't do a lot of things. So these are all the things that people are putting together that makes them to have. So in the first demo we had, that first session we had, we discussed a lot of these things already, and we showed how to work with the existing table format and the catalog. I think in that one we used Apache Iceberg and Apache Nisi. We were able to build something and it was working fine. But now, let me go back again 10 seconds. Then these people came in and they said, okay, this edit that you're having here, let us do something. So they came up with this. And now they removed these two. And then it became just one thing. And it's called Data Lake. Is anyone lost? Are we all here? Before we go to demo now.
Yes, we are here. In fact, we are getting it.
Good. So that means you are not lost.
So, sorry, can you scroll your screen back up a little?
This is this up or this down? Okay, good. Are you okay? So I can leave the screen. Let me know when I can leave the screen. That person that asked I should scroll up.
Yes, go on now. Thank you.
Okay, good. Good. So now, so I'm going to use what they call a DB to set up something, and then I'm going to show you what I've built end to end that anybody can use in their office, production based and everything. Although minor code or professional based. So now the first thing we do, like we have showed, so I'm going to use this one. I'm going to use a Lake, a DB, right, as my catalog, and I'm calling it my DB. So first thing, like I told us, you install a Lake, right? So this is a DB UI. For you to launch a DB UI, all you need to do is just to go to your terminal. After installing DB, just type db-ui. It will launch the UI. If you type only .db, it gives you the terminal one. I don't want to confuse people, so I'll just work with the UI now. And then, so like I said, so as soon as you have this, the first thing we do is we install our Lake and then we attach it. So if I do this now, can you see automatically it creates this is what you have. This is my catalog now. Now it looks like it's plenty, but it's so small. So these are all the things that you create. So it's tracking columns, how you map things, the tags, data files themselves, when you delete, it's tracking everything. The snapshot is here. So if you want to do what they call track flow, the schema, it also does what they call schema evolution. So if you make changes to your schema, you added 5 columns, remove 2 columns, it does not need to insert your record. Why? Because it has schema to control. So this is what, as soon as you create this attachment and you create this database, it automatically stores everything that goes on. So this is the catalog that points to people in the library and say, okay, go to 10th floor, go to 12th floor. That is where the book written by Joseph Joe is there. That is where the book written by Najib. It will tell you, this is the one that tells you, but this is the book themselves. So this is exactly where it will be storing. This is my database I created, but this is a catalog. So if I go in here now, let's create a schema. And then we'll create a schema. So if you come in here now, you can see that I should have a schema. Now, let's do something on the shows. Because I'm using a DocDB UI. If I want anything here, it might be thinking it's DocDB that is doing it. So I probably need to add my own schema or whatever to it. So if I come in here, I should see it. Let me see. Okay. So this one is just the memory of the DocDB itself. So whatever we want should be in this place. So I can see it here. So if I want to create a table now, so let's just create a table. So I'm just doing a regular demo. We are still going to do a projection like demo. That makes sense. So I want to create a table. I'll create that table. Don't forget our catalog is this. Right. I want our catalog to be able to know where our schema and tables. That's why we added catalog dots here. So if we do this now, if we come in here now, we should have a table here called customer. Can you see? So that table has 2 columns, ID and name. So let's insert record. I'm just inserting some record here. I put names of my guys in here. So okay, let's put. So one bad thing, like me, I don't like using all this notebook. But one bad thing about this DocDB notebook is that if you're running things and you don't address them, it will be assuming that you are using DocDB itself and not the Doc Lake. So that's why I'm appending the Doc Lake we created. No, that's the name I gave it. If you go up here, you'll see I gave it my Doc Lake. So if I run this now, here, so it created one with this statement, it inserted this 6 record rather. So if I select it now, I can see those 6 of them now. You see, so I can see Chief Daddy Mayor, I can see Chief Daddy Najib, Alaji Musili Kwawan, Madam Pelebe French, I can see Chief Daddy Lekura, I can see Chief Ojogago, you can see all of them inside of it. I didn't create it, I just created, all we have installed is a Doc Lake. And then we're already doing SQL. Now, let's say I can do an update. So let's say this one says his name is not Chief Daddy, is I Chief Lekura. So let's do, sorry. Okay, so if we do this now, and then if we go back again and select, you see the update has happened. It's no more, it's now I Chief. Now, there's one beautiful thing in this place that I love so much, and that is snapshots. So can you see? So as you're making changes, it's keeping snapshot of what you do. For those who don't know snapshots, snapshot is like, let me try and use diagram so that people can understand. I'll try to just like the layman definition. So let's say this is mostly Lagos. Right. I'm just trying to use something that will make sense. I'm thinking as I'm trying to do. So let's say this is Wednesday, right? Let's say this is Lagos again. This is Thursday. Let's say this is London. This is Friday. Let's add one more. Let's say this is Berlin, and this is Saturday. Now, if you go into the database, right, and you want to query where Musili is, this is what will come out. In the database itself, when you go there and you just see You just say Musili and you just say Berlin. That's what you will say, right? But with time travel, you can say, give me the state of this person as at Wednesday. So time travel means that if you have data in a place and a lot has happened to that data, you can go back and see the state of that data as at a particular time. So I can go back and see what is the state of this record 4 months ago, right? Let's say somebody works in that office. Let's say the person has gone to cook beans. The person has messed database up. I can go back and check database as at yesterday and then restore as at that yesterday, and they will be fine. That's one thing all those big warehouse they put in is called time travel, right? I like doing this when I'm taking a class. And why I do this is that I also like to encourage people, when you hear new word in a training, in a session, right? Always share you get. Always note it down. So when you go back, you go and check it. So you can just pick any of the link and read about what time travel is all about, what it does, right? So it has that future. And you don't need to break the bank for you to use that future. So as soon as I check my snapshots, I can see all of the changes that have happened. So it's telling me that a lot have inserted record. So it has different versions. The latest version of this table, I think I've been playing around this table before, and that's why you have some other old version there. So the latest version of this table is the 4th one, right? So it allows that. And then when you are done working, you can detach it. See, as soon as I detach the lake that I attached, everything is done. So I'll do another straightforward demo again. So this time around, what we attached here was a doc lake. We attached a doc lake and we use DocDB as our catalog and table format. But let's go ahead and use SQLite. So this is like a database, right? Now you need to now tell this one where you are storing your data, the data itself. So the same thing we did, we'll go ahead and do the same thing again. But this time around, we are using SQLite, and then we can create table. So you might want to do another one and put Postgres here or MySQL as a place where you keep your stores. Then you can go ahead, we create a table. You see the table is already existed, we just created it now. Then we'll go ahead, we insert these records into it. Then we can check. Right here you can see. Then we can make changes, updates. So it's just like you're just storing files somewhere and you can make a sense. But it will not make a lot of sense now until we do the real life practical that is not just running things in terminal like this. And then I can go back. I can also check what is going on in that table. I can look for the snapshots and check what is going on in that snapshots. You see, I can see a lot of changes I've made to that snapshot. I can even go back and do some other things. And say, okay, what are the tables I have? So if I create more tables, let's create one more table. There are a lot of methods that you can call, functions that you can call to do a lot of things. And then, boom, you can also detach it. So this is how it works, right? But sometimes in real life, you don't want to be working like this. You want to have a Python code, you want to have a database code that you work with. And that's what I'm going to show now. So before I go into that, any more question? Any question before we go? So good question. So now it's not local. It's not local, right? It can be used anywhere. We'll see that now. I'm just using it, just saying that you can use it locally, you can use it in the cloud, you can use it anywhere. I'm just answering a question here by Eddie. Any other question? Is anyone lost? If you are lost, you can ask a question before I go into the practical. Okay, good. So let's go into the practical.
There's a hand
question. Please, how are you able to use Postgres inside of the DocDB UI? I'm confused now, please.
Okay, so I will show you that one when I do my practical now. I have a question here. Let's see you face. I can understand face. That is the iChief Ilekura there that is asking question. Okay, Uthman, I will show practical, you will see it now. Right. Your hand is still up. That means I have not answered your question. Okay, good. Any other question? Okay, so let me show some. Okay, good. So let me show something. So I was playing out with the code, and then you can see in this code, right? I will try to explain the code end to end, and then we'll run it. So now look at this code. Any credential you see, don't worry. After this session, they will not be available again. So the only thing we are importing is the engine we want to use. And luckily for us, this one, when we have this one, we can easily install things. So DocDB allows you to just do install packages. Man, you can see it here. Just do install with DocDB. You have, so if I go, what you're asking is this, if I go in here now, and I just do this, I know this is not a DocDB class. So if I just come in here and I just do something like this. Sorry, let me copy the whole thing. So if I do this, and then I have something like this. Come on. Okay. I should be able to do an install straight. That's the beautiful thing about DocDB. You can go ahead and just install anything you want to install. Can you see? So Usman, can you see it?
Yes.
So
Yes,
it's not a DocDB class, but I just let me show. So that's how you install things. So when you see install Doc Lake, it's because DocDB allows me to install like this. Right. So Postgres already loaded. I can connect the Postgres, put the URL. But like I said, it's not a DocDB class. So let's get to our own thing. So that's the first thing. We install DocDB. Like I said, you can use any engine. You can use Trino, you can use Spark, you can use Presto. But for now, because this thing is just like 5, 6, 4 months old, probably for now, they only use DocDB for now. They're still working on how to ensure the other integrations work smoothly. So we connected our DocDB, and then we install the Doc Lake, which is the catalog and both the table format that we want to use. And then we loaded it so that it can be active. Then in this case, we don't want to use DocDB or SQLite. We want to point it to a database. So we are using Postgres. So this is the Postgres. So we installed the Postgres, we loaded it. Now, we want to store our data in S3. Like I said, for the Lakehouse, you are the one in charge of your storage. So our storage is going to be an S3. Let me see. So this is our storage. We're using this DEC Lakehouse. And if I go in there, you see it's empty, right? Nothing is inside. That is what we want to use. So all of the things we are doing here, the code we make available. I'll make the code. I will share the code with the team, and they can make it. I'll put it on GitHub and share the link. So from here, you can see setup. There are a lot of which you can actually do secret also in DocDB. There's something called secret. There's a secret method you can do, but just to make it very simple for everyone who is there. So I start to just do it, make it like easy waterfall, straightforward, so everybody can see what we are doing. Now, so I set X3. I said, okay, this is my X3 region. This is my access key, and this is my access secret. Like I said, after this class, all of these things will not be available again. So this one. So now look at what we've done. We've connected our engine I want to use. We have installed the Doc Lake itself, which is going to be our catalog and table formats. We have installed where we want to store our catalog, Postgres. And then the attachment we did in that practical is what we decided to do, attach it, right? I like to use if not exist when I'm building things in SQL because I don't want to be seeing some errors. So the same thing I told us that other place, if you go back to that other one, Doc Lake Postgres name. So we're using Postgres. And then we are passing username, password, those, and this, and I'm giving it Lakehouse. That's the name we are giving it. So if you come back to this one that we showed here, it's still the same thing, right? Let's choose the one that looks like database, where is .db. It's like Ilekura is sitting on top of this thing. Okay, here you can see this one you pass .sqlite. The other one you pass .sql. So you pass that particular thing you want to use. And then after that, we ask the database, we are asking the engine, please use this lakehouse that we just defined. You can give it any name. I just have to give it lakehouse. Use it. So then I started work. I said, create a schema, call it bronze. Because I want to create a medallion setup. I have bronze, silver, gold. And then I said, okay, after you've done that, right, do something for me. Connect to my source DB. So I have a source database that I want to pull data from there to my lakehouse. In real life, when you're working in real life, you have to be pulling data from one place to your lakehouse. So in this case, I want to connect to this database. Yeah. And then ask it to take data from here and store, not in this place, but this time store it in my own lakehouse that I have built. Yeah. So that's what I'm trying to do. So I need to connect to this particular database so I can pull data from here and put it to my lakehouse. So let me put it here. So I want to pull data from here and store it. This is my own lakehouse I'm building now. Right? It's just that my own storage is not mini IO, it's S3. And then my engine is .db. So this is my own hand built Snowflake. So I want to take data from there. So I need to connect to my source system. So this is me connecting to the source system to do that. And then after that, so now I always do something. When I'm working on something and I want to be dynamic, I like to use this information schema to see every table in that place and keep it as a variable. So we check that database, this database I just connected to, right? I've connected to the database. One of them, this first one is just a catalog, does not concern us. This one is where you have complete data that you want to work with. So I go in there, I use the information schema to say, give me every tables that, since I want to move all the tables. If I don't want to move all the tables, I will do a list here. I can do something like this and call it table equals to, then do a list and put all the tables I want to mix. But in this case, since I want to move all my tables, I just use information schema to get all the tables, right? So all the tables are here, they are there. And then I start to go ahead and say, okay, for every tables that are in these tables, right? Go ahead and create a table, call it bronze, because that's the name of the schema dot the table itself. I'm using a string here to ensure that it is dynamic. So it's just like say for I in table. So for table for I, and then put underscore there, right? And then take the data from my displays, that's my own schema, and then create it as select all from there and insert. So that's what I'm doing. So let's run this. I think I'll make some changes. Okay. So it's going to go into that. So let me show us this one. Yeah. So this is where I'm taking data from. Right. This is where I'm taking data from. So it's picking all the data that so this is like my source database. So this is the Lakehouse demo. So it's picking all data that I have in this place, and it's moving them to my S3. That's what it's doing. Now, as soon as it does that, I created a table, something here. Initially, I can rerun it so that we can see it. There is a schema here that is called public, right? So it's the one that is storing all my catalog. But let's do something so that people can really get what I'm saying. So all of them is there. If I go to S3 again, now I have everything. So if I come in here, I see all the tables. So you can see bronze now. I can see all the tables are here. But let's do something so that everybody can really understand what is going on. I'm going to delete this again. Let me delete it and do everything and rerun it so that people can see exactly, and then they can clear their doubts. Because the most important thing is not you moving data to S3, is the, like I said, the engine and the catalog, the table format rather, and the catalog. They are the two most important things. And I did not show us that this was empty before we started. So let's drop this. Let's drop this. So nothing is here now, right? So this database, I just created something on Superbase, just something very small. So let's put our schema here again now. Create new schema, let's call it public. So this is where the catalog is going to sit, right? Now, if you notice that there are two databases here. The first one is where my original data that I want to build a lake house with is staying. This is this one. The second one is where I want to keep my catalog. So this first one could also be my SQL. It can be a MongoDB, whatever they use in your company to store data. This is this one. The second one is just a catalog that holds information about my data, my metadata for the lake house I want to build. So when I query a table, it can make sense. So let's run it now. So if you come in here, you'll see that if you go into public and go into tables, you will not see anything. But let's see what happens now. So Doc Lake will go in there and then create catalog by itself when we run this one now. And then it will now load data back in S3. So it has created the schema for us, and it is going in there to drop data in there. So my data is already in there. So if I go back to this place now, and I try to refresh this one, okay, let's come in here. You see, I have a bronze now, and all my record is here. And if I go back to, let me see what is in my catalog now. Let's see whether catalog has data now. You see, so by itself, it will go ahead and create this. Whether you're using Iceberg, whether you're using Polaris, they do all of this too. But you have to set up a lot of server for them to be able to do this. But just by attaching a directory or a URL or URI where you have your database that you want to use a catalog, it goes ahead and decides to do all of this for you. So I don't have business in this place. It's just for it to be there, right? So now I've been able to move all my data from my source systems. If you look at this, is my source systems. I'm going to move all this data from my source systems in here. All these tables you see here, they have been moved from my source system, and now they are in this place. Now, if you look at each one, they see that they are package files. You can't really do much with it, unless probably want to use Glue, but you cannot just connect to it and write SQL. If I want to write SQL on top of this one now, and I don't want to use Glue or Athena, Athena rather, then I have to use Glue and combine something with it, maybe Spark, to read it. I will need, for me to read this data, I will need a catalog that holds it, and I will need an engine. But Doc Lake make everything very easy for us. So data is in our bronze now. Now, because we are building the architecture we showed, so we need to have a silver layer and a bronze layer. But the first question is, how do we run our code? Because the only engine that is available for now is a DocDB. So let's connect to a DocDB engine, right? Beautifully, I'm using dbeaver. This is just a client to connect to the database. So if I come in here now and I type DocDB there, DocDB will come up. DocDB does not need to, so I can just give it any part. I can just call it Joe. I just put Joe here and I do test connection. It just needs a file to persist itself. That's all. So if I do this now, I'm connected, and then I can bring up an editor for me to write my code. Is anybody lost? You understand how we take data from source to the lake house, right? So we have data in here. This code is what helps us. And I think I took time to explain what this code is doing already, right? So now that we have data in that place, I prepared some SQL because I didn't want to waste time. Prepare some SQL already. So I have my silver layer SQL. They're just straightforward SQL. I'll quickly show them too. So I'm in this place. But before you write code, you need to connect because DocDB does not know where you kept your data. So you need to use this to connect. DocDB does not know where AWS anything is. So you need to use this. I kept this here also. I also put all of this in the same thing I used to connect. So you come in here. So let's connect this DocDB instance that is here to our X3 cloud using our Doc Lake. So if I do this now, and I run this, now this DocDB instance is aware of what is in my X3. So it can pick everything in my X3. So it's going to create a silver schema for me. It's going to create customer that is clean because I've done some trimming. It's going to create product that is clean, category that is clean. It's going to supplier that is clean and order that is clean for me. So let's go ahead and just do that. Now, everybody here knows that S3 is just a folder, right? But this thing is running SQL code. Why? Because of the Doc Lake. Why is it possible? Because it has a table format and a catalog embedded inside of it. If you see, I do not have any iceberg. I do not have any catalog like Nessie. Just my Doc Lake is allowing all of me to run query against the folder. So this thing just ran query against this bronze folder, and then it created a silver layer for us. We're still going to create the data that is in here. So let's create our good layer so that we can start checking what we have created. So I also have some SQL code for my good layer also. This is not an SQL class, so coming to come and write them here won't make any sense. So the same thing, I want to create what they call customer lifetime value. For those who know, you want to see how your customers are performing when they have been with you, how much order they've made, and all of those things. You also want to create monthly sales summary. Those are business things you create. So in the good layer. So let's run our good layer too. And then if you go in there also, the first thing it did was to create a schema and then start creating those tables. If we go back to S3, now you're going to have 3 buckets, 3 folder or 3 directory in this place. And then let's refresh it. Now we have our bronze, gold, and silver. So let's see whether we can query some tables directly. So, oh, sorry. So let's see if we can query some tables. I think also these those table mirror here, although they are not here. Okay, they are not. I think I see their mirror here. I'm not sure. Okay, they are not here. This is just an instance to run. So we can check those tables now. If I do this now, select all from bronze dot customers row. I don't know if it's customers row or something. I don't know. But let's check. You see? So now what am I doing? I'm running query against S3 buckets. I don't install anything. No server is running. No Docker compose up. The who has not built Docker for me. Nothing is going on. It's just me running it. Why? Because of what? Doc Lake. So let's see whether we can query something in our good layer. Let's see what is in our good. So we have top products. So let's go back. We can do gold. Sub underscore product. Is it product or product with X? Okay, product with X. So if we do this also, I will run this. And then you can see. So everything has been built, right? I can also decide to put my silver and gold in my Python code. Let it be doing incremental load. I can do all of that. As far as I'm calling that Lakehouse catalog I created, it will do all of this for me, and now I'll be able to do whatever it is I want to do. So now, some people might ask questions. Now that we have table in here, right? And then we also have this and this, gold, silver, bronze, right? Of course, your business will connect to gold to make sense. How do they connect? So this was the edict I had. So I tried a lot of ways to connect, and they were not straightforward. And I didn't want to come and showing DSN connection. You have to use DSN to connect. Why? Because a lot of the tools, this thing is just like 4 or 5 months old. So a lot of the tools that you use to build warehouse dashboard, they are not available. So instead, I went ahead, I tried to build 2 different dashboards using Streamlit. I do a lot of things with Streamlit. I think this one is for one of my customer. I did this for Streamlit. So I like doing a lot of stuff with Streamlit. If I want to be lazy, so I do Streamlit a lot. So let me show the last part of the work. So I decided to go ahead and do this. So this one will connect to our gold layer, and then to come up with this. So now that means I have our company data in S3, and then I'm building dashboard for business to use. So this is an overview dashboard that shows everything, our total revenue, total active, and then we can go ahead again, scroll down and then see sales trend. We can go ahead and see product performance, how the product are performing, and then we can even go ahead and see executive summary. Now, all of this is not connecting to the warehouse. It's not connecting to the database. It's connecting to an S3 bucket. Without me installing a server that was running, the other time we had to have Trino was itself running on a server. Apache Nisi was also running on a server for us to build something like this last time. But now nothing is running in any server, and I have this up and running. So, ladies and gentlemen, thank you. This is all I have to say regarding Lakehouse 2.0 using Lake. I don't know if you want to answer a question. Any question from anybody?
Yes, I have a question.
Please go ahead.
Okay, so thank you very much for taking your time to put all this together and bringing us together here and showing us this amazing solution. So my question is, what difference has this now done in regards to transformation when comparing to DBT? Does it mean that I don't need DBT anymore, for example, if I'm to use Lake? Or DBT can still play a role? Sorry. DBT can still play a role in combination with the Lake. I just want to...
In fact, I have started preparing a slide so that I can go and embed Najib again, that I want to put in DBT into this. So my next topic, if Najib allows me, will be Lakehouse with DBT, Lake with DBT. And I won't bother myself explaining what Lake is. I'll just go into how you can use DBT. So if you want to use DBT, right, normally for you to ask this question, that means you understand what DBT does, right?
Yes.
Right. So if you come in here now, you know, I was running my gold layer, my silver layer. That's what DBT would do for you. Okay. Because you want your gold. So in this case now, let's say my bronze is running an incremental, a new set of data flows from my bronze into from my Python code into the bronze layer, right? I need to manually run these 2 SQL for it to be uploaded. I need to run silver all over again, run bronze all over again. So I want something that can connect to silver and be running it for me at interval. So let's say, let me explain. Let's say this is our company data now, right? Let's say this is code that is taking data from our application and dumping it somewhere in the warehouse for us, but this time just in the storage. Now, as this one is running, right? Let's say it's running incremental. That means whenever there are new data in that application database, let me show for the sake of those who don't really understand what I'm saying. Let's say this you know that you are taking data from here and putting it in your warehouse or your lakehouse. You are putting it. Now, let's say new customers or your old customers have decided to do transactions. As they do transactions here, that means you have data in this place that are not here yet. So your Python code will be able to run at particular interval. Let's say you put it in Airflow or you put it in Prefect.io, you put it somewhere, or you just put the cron jobs that run it for you at a particular interval. So it takes this one, and then by the time your Python code runs, it will dump the data in this place, in this bronze layer. Now, you want something that will do transformation for you for silver and your gold layer, and that's where DBT comes in. For this particular scenario, all I needed to do was just take this code, right, and run it. So this is my transformation code here, as you can see. So I ran it manually, right? But if by God's grace you're able to come back, I will incorporate DBT and be able to allow people to build this full production grade, not running transformation manually in this place. Because you can see I have to spring up a DocDB client here for me to run my transformation. So your question is, can I put DBT? Yes, I can put DBT at the point where I'm creating my silver and gold layer, so that DBT is the one doing the transformation, not me running here to come and run it. I don't know if I answered your question.
Very well, very well. Thank you.
All right, thank you. Any other questions? So I can hand over.
So, sorry, just a question again. Sorry, I know there are a lot of people that want to ask. Just a clarification, a question, sorry. The dashboard you built, did you do that with Python, or what tool did you use?
So I use something called Streamlight. It's actually a Python library.
Okay, okay.
It's called Streamlight. So we call it Streamlit. Anyone that comes to your mind is fine.
Oh.
So this is it. It's very powerful. I used to build a lot of things. I used to build for even production grade work. I used to build this one time. So this was a lot of things. So that's what I used.